Welcome back to the fourth part of the Resident Evil puzzle series in C++ this time. In this part, we're going to finally finish the entire interaction system with the display and the picking up and all that logic. And for that, we're going to have to do a lot of work in our character. And then we're going to have to finish off our setup here in our widget, because we couldn't do that without some setup in the character first. And it took a bit too long last time. So let's get straight into it. So one thing we can quickly change in our interact widget, which after testing I realized didn't work, was this. This isn't necessary anymore. We can just get rid of it and just leave it as a normal variable. It doesn't need to be referenced in the Unreal editor. So save that and let's go straight into the character. So let's start with our forward declares or forward declarations. So we're going to have class UInputMapping context semicolon. We're going to have class UInputAction, and we're going to have class USoundBase. Now the first one is mapping context, which contains a list of essentially all our inputs. It's something we're going to set up in the editor, and it's made up of UInputActions, which is why we have UInputActions as well. And USoundBase is just so we can play a sound when something happens. So that's why we have this class. Now, next, we're going to need a delegate, and we haven't made any delegates yet. A delegate is essentially the equivalent of a blueprint event dispatcher. And the way we set it up is slightly different than obviously in blueprints, because in blueprints it's just a plus in a menu. Here we actually have to write something. So the way we do this, and I will leave a link in the description for a very good website for how you set up your delegates, because there are a few rules in what kind of terms you want to use in them, depending on the situation you need. So I'm just going to show you the one we use, and that's all. So if you want to learn more, please read the link in the description, because it is pretty useful and interesting to check out. What we're going to call is we're going to type in all caps, declare multicast delegates underscore 1, and no longer in capitals, 1 param, open and close parentheses, and semicolon. So what this does is declare essentially is going to be mandatory at the beginning of any delegate. Multicast means that it can be referenced any number of times, and delegate is just because it is a delegate. Now, we put one parameter. If you have two parameters, it is 2 params, and if there's no parameters, you just remove this. Then we have to give it a name, and the name we're going to give it is fInteract changed signature. Put a comma and type in a actor pointer. And just for clarity, we're going to put a comment. So the way we put a comment is by typing slash and a star, and it will make a second one appear here. And so what this does is it means it's a comment only between these two, so this doesn't have any errors. Because if we were to, for instance, do a double slash, it would hide all this line, and we don't want that. So like this. And we're going to just say this is the actor that changed. Now you don't have to put this in, it's just so that whenever you look back on it, you know what it is. This name here essentially can be anything you want. There can be no duplicates of the name within the entire code base, so you need to be careful. Well, the chance of having the exact copy of something that's already been made is unlikely, but just be careful, that's something to take into consideration. It also needs to start with the letter capital F. I just put signature at the end, you don't have to do that, it's just how I do my naming convention. And actor is just the one parameter that we want is an actor. Now this alone is unusable, it doesn't do anything. We now need to make it so that there are variables that use the signature, which is the actual clicking the plus button on the event dispatcher, if you will, in blueprints. So we can do that first, that way it's out of the way. We're going to make 2, and we're going to make sure these are public. So I'm going to make these all at the bottom, because we're going to go through a few different variables here. So we're going to say public. We're going to say fInteract changed signature. That's not how you write that. Signature. And we'll call this on start overlapping. On start overlapping. And then we're going to copy this, and we're going to make another one right below, and this one's going to be called on stop all overlapping. So on stop all overlapping like this. Now, these two are the actual functions we needed in our widget, so we're going to go and do that now. So essentially, what we're going to do with these here is whenever the character overlaps something that it can overlap, we will call this event dispatcher, so that way this interact widget knows that something has changed. So exactly the same as what we did in Blueprints, but we're just doing it here in C++. So for that, we need to bind them like we would do in Blueprints as well. Same thing here. So we're going to go and search for as character reference, because that's the one that holds the actual delegates. Put an arrow because it's a pointer, so we get the information we need. Wait for it to load, and we'll say on start overlapping. Press tab to autocomplete. And the way we assign this, so this isn't a pointer, so we use a full stop instead of an arrow. And we're going to let it load. And there are a few options. Broadcast is the one where you send the message. In this case, that's not what we're doing. What we're going to be doing is adding. So add UObject is what we're looking for. Parentheses, semicolon, and inside of the parentheses, you need two parameters. The first one is an object, a UObject. So that's going to be this, because a widget is a UObject. And then we need to tell it what function it is being connected to. And to do that, you want to put an and sign. You then want to type in the name of your class. So in our case, we can copy URE_InteractWidget, paste that, double colon, and in here we want to find the function we're looking for. So in our case, we named it very easily. We named it receive, and we just need to choose which one we prefer. So NewClosest is what we will use for start overlapping. The naming isn't the best, but that's how it's set up. So NewClosest for start overlapping. No need for parentheses. It just needs to be the class, two colons, and the name of the function. Next, we do the same thing. So as character reference on stop all overlapping this time. Same thing, add UObject, parentheses, this as well, and URE_InteractWidget, two colons, and this time receive end overlap. And so now, whenever we call this function and we broadcast it, this delegate and we broadcast it, or this one, it'll call these functions. And that does it for our interact widget. We don't need it anymore. We can go back to the character. Now let's make all the other stuff we need. So we made this last time just to save on time. Now we're going to finish everything else up. So we will start by getting an inherited function, which is the SetupPlayerInput component. So to get that, we can go to our horror character. I don't believe it is in here. So if we look, it is actually here. So we can copy this as it is because it's already overridden. And in our character, just place it here. Now it's going to give us an error because we haven't gave a definition, but we will get to that in a second. First, we're going to make all our stuff in here. Private. Actually, before, make sure your class is abstract because we don't want to be able to use it as is. We have a child of it in Blueprints. So in private, we're going to have a Boolean called CanObjectInteract. A function, sorry, not a Boolean, but it returns the type bool because it's going to be a true or false. The parameter is an A actor or an actor, and we'll just call this object. It is const because it's not going to change anything, it's just going to check information. Next, another one is going to be bool CanSeeObject. So A actor pointer object again, and const because we're not going to be changing anything inside of it. Bool IsObjectCloser, an A actor again pointer, and then we're also this time going to take a float output, so we have an and we'll call this closest distance, and a const once again. And finally, one last one, which is A actor pointer DetermineClosest target. And so all of these are functions that I also did in Blueprints. So we're just redoing them here. The reason this is separate, could technically all be in here. It's just that it's more readable and easier to understand as we go through the different functions instead of just having everything in DetermineClosest target. Next, we're going to make our protected section, or I believe there's only one. We're going to start by making the constructor. So we're going to say ARE underscore character. So we can actually just copy this. And this is the constructor. And sometimes it'll spawn by default. And I'm not even sure. I think if we go here, we could get it to, if my Visual Studio wants to actually cooperate with me. But you could, I believe, from here tell it what to spawn, like what default functions you want to have. But I just have to do it manually because my Visual Studio is slow. So it's going to give us an error because we haven't given any definition. Same thing as usual. Next, we want virtual void BeginPlay, parentheses, override. And that's just BeginPlay. I'm pretty sure everybody is familiar with that one. So virtual void tick, parentheses, float, delta time, and override. Same thing, it's a virtual function, so we have to override it. And two more, virtual void PossessedBy, parentheses, a controller pointer, new controller. And this is an override as well. And we'll do the opposite as well when we unpossess, which is virtual void unpossessed and override. There we go. So that does it for our inherited functions. Now we're going to do our parameters, so to speak. Now we're going to have our exposed stuff. So we're going to go and say uProperty, edit defaults only, because it does need to be changed at runtime. It's going to be the inputs that we're setting up now. So category inputs. And we're actually just going to copy this because we're going to use it a few times. Start by saying T-array, and T-array just means we're making an array instead of a single variable type. We're making an array of them, and you put the inferior and superior, and within it we get to say which type we're looking for. So if we would say bool, it would be an array of booleans. What we're looking for is an array of uInput mapping context, and this needs to be a pointer because it's referring to an object directly. Then we're going to say mapping, we'll just say player, we'll call it player mapping context. And we're just going to add the other stuff. So paste our uProperty again, it's the same. And this time uInput action type with a pointer again. Interact action, we'll call this. So the reason we do it this way is so that now we can go into Blueprint and say, these are the input groups that we want to add to the player. This is the individual input that we want to take into consideration for interaction, and we're going to bind this to an actual input function that we make separately, because unlike in Blueprints, we can't just drag events into obviously our C++ for like pressing a certain key. Next, we want our sound, so we can paste this, but we'll replace it with sounds and copy it. We're going to say uSound base pointer success sound, and here we can put a null pointer as a return, and actually we can do that here as well, null pointer. And for the last one, so paste again, uSound base pointer failed sound is equal to a null pointer by default. Now, to finish off, we want to have this so we can actually modify it in Blueprints as well. So we're going to say uProperty, copy, paste, and we'll change this category to interaction. Next, we're going to have some more, now we're going to have some private stuff. This is public. The reason this is public is because we want to be able to get it inside of our widget. So this has to be public. Now we're still getting a few errors here, and we'll get to those in a bit. So for private, we want to have a T-array of the actors that are currently in target range of our interaction. So that's going to be an array, so T-array, and of type actors. And we're going to call this overlapped targets, semicolon, and a actor pointer for the closest target, so call this closest target, and this will be a null pointer by default. And so essentially we're going to use our function we made here to determine this based on these. And to do all that, we just need to make our functions now. So these are also in private, but because these functions are going to be receiving functions, sometimes you might, oh, actually I put actors, it shouldn't be actors, it should be actor. It's always singular. These functions are going to be U functions. I'm going to explain why in a second. So if we make our functions here like this, technically you would think, oh, well, why are we making them a U function? Because a U function can't be used in blueprints if it's private, because if it is private, it means it's staying only within this class. Protected means it is inherited by the child, and public means anything can see the function, and that means the child. It also means any outer actor can see it as well. Now, the reason we're doing this is because some delegates, if we go to this here, you could say declare multicast dynamic delegate. And so that means that it is linked or can be linked to blueprint functionality. And so in that case, if it does have the dynamic keyword in there, then you have to use U functions to be able to handle those delegates. And so what we're using here is going to be associated to a dynamic delegate, so it needs to be a U function, even if it's private. So keep that in mind. So all three of those are going to follow that rule. All three of these functions are going to follow that rule. So void receive, as usual, on begin overlap. And I'm going to copy this over. So I'm going to leave it on screen for a second because it is a lot. And so make sure you copy this exactly as it is, otherwise you'll get an error. So it needs to have all of this. So I'm just going to put a parentheses back here, and we're going to go through it one by one. So we have begin overlap, and this you can name anything, but on begin overlap is what it's going to be for. So we have a U primitive component pointer, the overlapped component, meaning essentially what is being overlapped. So this is essentially like when you drag or calling from your any of your blueprints and you call on actor begin overlap. This is essentially all that same information. So it is the overlap component, it is the other actor, it is the other component that we overlapped, it is the body index in the event that you have something like a instance static mesh. Was it from a sweep detection? And if it was, what was the hit result of that sweep? Then we have the same thing for on end overlap. So U function again, void receive and on end overlap, and this time we can just copy it the same from up here, but we only need these. We don't need anything after that, so copy and paste this. And I think that's right, yeah, just this. And this is the same thing as before, it's the same parameters, so I'm not going to re-explain them. U function for the last one is going to be void receive interact. And for this we want a const f input action value reference, so and just type in value. Now this function is specifically for handling the inputs of our input action, being our interact right here. And I believe that is everything we have as far as setup goes in the header file. So let's go ahead and make all our functions. So we're going to start with just doing these ones, the inherited ones, and then we'll move on to the rest. So character. I also just remembered we have this inherited one here. Let's just group them all together so that we don't miss it. And there we go. Now we have all 6 of these functions ready. Let's begin setting them up. So on character initialize, essentially, so on the constructor, we're just going to do something very simple. We're going to get capsule component, which is already there by default because we're inheriting from the basic player character, which always has a capsule component. And we're going to say arrow because it is a pointer. Now, this won't work because our capsule component, we don't know what a capsule component is, because most likely in our character class itself, it doesn't have in its header what a capsule component is, It only has it in the C++ class, meaning it isn't inherited. So we want to do hashtag include components capsule components.h. And so now once this is done, you'll realize there's no longer an error. We can put the arrow now on component. Actually, I'm just going to do this on components begin overlap. And as you guess, this is a delegate, or at least a reference to a delegate, because if we look at the return here, we're getting a F component begin overlap signature. So it's essentially like if we were getting this inside like we did in our widgets. Now the only difference here is, as I mentioned, this is a dynamic delegate. So instead of saying add UObject, we're going to say add dynamic, or for safety measures, we can say add unique dynamic. Now this shouldn't ever be necessary because add dynamic would be enough because we're doing this on spawn of the character, meaning it only happens once, because if the character is deleted, well, so is the delegate, so it doesn't matter. For the results, for the parentheses, add a semicolon at the end, we're looking for this as usual, and we're going to say and ARE underscore character, 2 colons, receive underscore on begin overlap. And as you can see, even though this is add unique delegate dynamic instead of the add UObject, it's still the same. It's still this and the function we're referring to. So copy this, paste it below, and replace on component begin by on component end overlap. And we'll do the same thing here. Just remove our receive, add it again, and say receive underscore end overlap. There we go. I ended up making a mistake here. In reality, the get capsule component and the delegates on begin and on end overlap should be set in the BeginPlay. And right here, I'm going to delete BeginPlay because I make this mistake. But in reality, we should be adding the super double colon BeginPlay open close parentheses semicolon, and right below that should be our begin overlap and end overlap binds. So make sure you do that instead, and then you can delete the ARE character instead of deleting the BeginPlay like I just did. Next is, let's do our setup. So in our setup, specifically the reason we have this is because the BeginPlay can occur before the input component is ready. And if the input component isn't ready and we start trying to set up our inputs, then it won't work and we would end up with no inputs, and that would be stupid. So we don't want that. So we have this function specifically for that, to say that the player has its input component ready and we can set up our functionality with it. So before we do that, we need to have our input systems. So that means the includes for them. So to do that, we're going to say hashtag include enhanced inputs subsystem.h. Then we're going to look for hashtag include subsystems / local layer subsystem.h, and a few more while we're at it. Not that. Hashtag include engine / local layer.h, and one last one, include enhanced input components.h. Now we still have some more to add, but for our setup, that's all we need. So we start as usual with our super function and call setup layer input components, and parameters the same. So input component, add the semicolon at the end. And now what we're going to do is we're going to check if our input is valid. So the way we do that is we're going to say enhanced input component pointer. We'll call this as input is equal to cast to enhanced input component, our input component. So if the input component that is being set up is of type enhanced input component, then we can work with it. So semicolon if our as input is invalid, we want to return. Now, there's also another check we need to do here is we're going to check if our input is valid. So we're going to check if our interact action is not valid or our input is not valid, then we return. On the other hand, if the input is valid and our interact is valid, then we can keep going and we'll say input. I think I might have mistyped that. Okay, I did. So it's enhanced input subsystems, plural. And so for this to work, we then go and say arrow, arrow, and we're going to say bind action. Interact action is the action we want to bind. Put a comma. We're going to say what we are looking to bind, what event. And so this is if you have your blueprints in mind and you have the multiple pins of start, triggered, stop, release, cancel, etc. That's what we're going to put in here. We're going to say trigger event, and we're just going to look for triggered. So cancel, completed, ongoing, started, or triggered. So triggered is what we use. Then we'll say this to say that this is the actor that's going to be using it. So this is essentially setting the same as we did in here. It's a delegate. And so this point of it is for that. So we're going to say it's this object, and the delegate we're going to use, or the function, is and ARE underscore character, 2 colons again, receive underscore interact, semicolon. Now I'm not sure why it is saying, sorry, no, this is my fault. As input, not input. Start with that first. An interact action should be valid, unless I didn't type it correctly. Interaction action. So that's on me. So that is done. So that's also our setup constructor is complete. Setup player input is complete as well. Let's add the last includes now. So we have, I'm going to split these up because now we're going to have a few other components. So the components we're going to use is hashtag include camera / camera component.h, and the camera component we already have, so we don't need that. We're going to add hashtag include, as usual, kismet / gameplay statics .h. And so this is just, so if you're unaware, gameplay statics is just various functions that are useful from, they go from like line traces to a lot of other stuff that is just really helpful logic. So instead of having to make them yourself, this include has a lot of them. And most of them are static functions, so you don't even need to have an object or anything like that. And last thing we need is we need our interact interface. So hashtag include tutorial / re underscore interface. There we go. This is all we should need. So let's get to these. So we'll do possessed and unpossessed. We'll get to tick last because it's the longest one to do. Okay, so for possessed, start with our super function and possessed by parentheses new controller, semicolon. And we're going to start by getting the player controller because this is not a player controller and we need a player controller. So a player controller pointer, and we'll call this as player controller, is equal to cast, not call sign, cast a player controller, parentheses, semicolon, and we're looking for our new controller. Like this. Next, we're going to say if that doesn't work, we can't do anything. So we ignore it. So we're going to say if this is invalid, so as player controller, if it is not valid, just return. And there's going to be quite a few of these checks. So what we're going to do next is we need our enhanced input. We need some information about that. So we're going to say if enhanced input local player subsystem, so quite a mouthful here. We'll call this as subsystem is equal to our local player double colon get subsystem, and this needs a inferior and superior because it needs to know a class that it is looking for, and we're looking for we're just going to look for this, so copy this and paste it in here. And the target we're looking for is as player controller an arrow get local player. And so what this essentially is doing is it's getting the enhanced input local player subsystem. If you've ever used it in Blueprints, you know what it is. It's that big block that you use to say add input mapping context or remove input mapping context, etc. That's what this is. So add the curly bracket so we can actually use it. And we're going to say for our input mapping context pointer, and we'll call this array element colon and player mapping context. So essentially what we've done here is we've done a for loop through an array, so a for each loop, if you will. And instead of doing a typical for loop, which would look more like this, where you have an integer and a length and an increment, this just allows us to go through all the elements of the list without having to bother about that. So the first thing we're going to do is we're going to make sure that we're not using an invalid element. So we'll say array element, and we'll say if you're invalid, we will continue. Continue just means we skip everything that comes after here. If we wanted to stop the loop, we would say break instead, but we don't want to do that. We just want to skip this element because it's invalid. Then we're going to say subsystem or as subsystem arrow add mapping context, and we'll say current context. We'll say array element comma 0. What this does is when we possess the character, we give it its inputs. Next, we're going to say set actor hidden in game to be false. And this isn't useful for right now, but it is useful for when we start swapping around with the pedestal. So when we go and unpossess, we're going to hide the character so that we don't see it in the pedestal. So just that. Next, we're going to say if closest target is invalid, return. So this is just check if this is valid, we keep going. If it isn't, we return. Then we're going to check if it inherits from our interact. So we're going to say cast to IRE underscore interface, parentheses, closest target. And the reason we have to do this separately is because if this is invalid, we can't do the cast. Or actually, to be fair, we could skip this one, because if this is invalid, the cast will be invalid as well. So we can just return this instead. Semicolon, and make sure you put an exclamation point because we want to make sure this is invalid, not valid. Next, what we're going to check is just if it is ignoring the interaction or not. So we're going to copy this, paste it here, and we will say ignore interaction. And if it does, if it's true, then we return. So in this one, make sure you do not have the exclamation point here. Now, if this is all well and good, meaning the closest target is valid, it is an interactable object, and it doesn't want to be ignored, then we can say that we want to say on start overlapping, and we'll say broadcast. And it needs a parameter, and that is the closest target. Now, we do want to add something else here to avoid doing an unnecessary little bit here. We're going to say if our on start overlapping is bound. So like this. And what this does essentially is just check that, is there a reason to broadcast? Because if there isn't a reason to broadcast, why do it? So we're going to make sure that we only call this from within here. So copy this and place it within the if statement. There we go. So what this does essentially is when we possess a character, if it was overlapping with a target that was valid for what we needed, then the second we possess it, we will let the widget know that there is a closest target and it needs to be displayed. Next, we do the unpossessed. So for the unpossessed, we're going to call our super again unpossessed, parentheses, no parameters this time, but this has to be at the end because it is a, I guess you could say, an end instead of a beginning. So we want to make sure it happens, everything here happens after, not before our logic. So we'll start by saying set actor hidden in game to be true. Now, obviously, if for your purposes you don't want it to be hidden, that's absolutely fine. You don't hide the character, you don't show it here, you just leave it visible. It's not a problem. We're going to keep it hidden though. Then we're going to copy this over. Just both of these actually. There we go. We're going to actually just copy the whole thing here. So copy all of this. Now, new controller won't work because there is no new controller, but we can just say get controller because this is a pawn and a pawn has a controller, so we get the controller here. Now, this can be false, as in meaning there is no controller relevant at the time. If a pawn isn't possessed, it's absolutely possible. But in that case, it would be a null pointer. This would fail, and it would fail if we did the super before, but we're doing this logic after, meaning it's still got a controller at this point. Now, instead of add mapping context, we're going to say remove mapping context this time. And for removing, we don't need the 0 at the end, so just remove it. And that's all we have to do for the possessed. So now we have a few extra functions we need to do, and that is we're going to do our 3 receivers, and then we're going to handle the tick and these 4 ones here. Receive, let's go and create this. Create the end. So that's our functions ready. Let's get into them. So these are pretty simple, to be fair. For our begin overlap, we're going to check if the overlapping target is or uses the interact, although we don't care. So we're going to say if the thing is what we're checking is false. So what we're going to check for is cast our IRE_interact, and we're going to check with our other actor. So if this is true, then we keep going. If this is false, which is why we have the negative, we're going to return. And if you're wondering why I do this instead of having this be true and have a parenthesis and have everything within here, it's just because it's easier to read and easier to follow. So then what we're going to do is we're going to copy this and we're going to add an arrow and we're going to say begin overlap, and it's overlapping this. So we just type this. Also, I don't think I mentioned this specifically, but it's the same as calling self from within blueprints. We're going to add it to our overlapped targets. So we're going to say add, and it is other actor. And that's all we do for begin. Very simple. For end, there's a little bit more we need to do. For end, we're also going to check for this. So if it is not interactable, we don't care. We're going to copy this and we're going to say end overlap instead. So end overlap. And then we're going to do also the same as here, except instead of adding, we will remove like this. And next is going to be a little bit extra. So we're going to say if our other actor here, meaning the one that is leaving the environment, is equal to our closest target, that means that we are, or if it's leaving the area, that means we are far away from it. And if it is still considered our closest, then it's most likely that there is nothing else in the environment. So we're just going to say closest target is a null pointer. It doesn't exist because we're not close enough anymore. So we set closest target to null pointer like that. And next, what we're going to do is we're going to say, well, if there's nothing left to interact within our range, well, we stop interacting, we stop our overlapping, and we tell our widget that it is done. And so the way we do that is with our delegate. So if first we check our overlapped targets are empty, is empty, make sure you use is empty because empty by itself means it will remove everything within it. So is empty, if it is, and our on stop all overlapping is bound, then we can broadcast it and let the system, let everything else know that we're not overlapping anymore. So copy on stop all overlapping, add a dot and say broadcast, and it also has a parameter, and that is our other actor, the last one that essentially left. Final one, receive interact, about the same amount of work. First we check if we have a closest interactor, so closest target is valid, return, sorry, if it's invalid because there's the exclamation point before. Then we have if closest target, and we want to get distance to this. If that distance is superior to interaction range, then we can't do anything with it. So we return invalid. Now remember, I haven't explained this clearly. I explained it briefly in the widget section, but essentially when you overlap with something, that doesn't necessarily mean you can interact with it. What determines if we can interact is if you are overlapping and you're in this range. So that's why we have to check if this is valid, meaning there's something to interact with, and if it's close enough to be interactable with. So leave that there. Then what we're going to do is we're going to go and make a boolean, which we'll call success, and it is equal to false because we're going to assume by default it is false. And we're going to say cast to our IRE again interact interface. We're going to get our closest target, and then we're going to say interact. We're going to actually interact with it, and this needs to know what we are interacting with, so this. And it's going to need an input that can change, or an output, sorry, which is the successful, which is why we have to create this parameter here, and we pass in success. And so what this means is if the interaction works, this variable will turn into true. Otherwise, it will stay false, or I think we set it to false within here. So either way, it will turn out false, but for safety measure, we still put this as false. And so then what we're going to do is we're going to say if success, like this, we're going to say that we want to play a sound. To do that, we're going to get our UGameplay statics, and we're going to say semicolon, double colon, and say play sound 2D. And it's just going to be our this, because it needs to know what is playing the sound, because it needs a world context object, which is just a fancy way of saying it needs to know something that exists in the world to be able to play this sound. And the sound we're looking for is the success sound. This isn't perfect. It works for what we're doing, but it doesn't work for anything you would make bigger than this, because we're making the assumption that when you interact with an object, you are either swapping POV, meaning you don't want to see the interface anymore, or you are picking up the object, meaning it disappears. So what we're going to say is if we succeed, if on stop all overlapping is true, if it is bound, then we're going to broadcast, and we're going to broadcast our on stop all overlapping dot broadcast here, and we're going to pass in the closest target. Now, this isn't perfect by any means, because it assumes that any interaction will either destroy the object we interacted with, or it will change our POV, meaning we don't want to see the interface anymore, so we hide it with this delegate. And that may not be the case for everybody, but that's what we're doing for this tutorial. So else, on the other hand, if it is a failure, we just want to play the fail sound. So copy this and just say failed sound. So that does it for most of the logic. Now we just need to do the tick let's start with our super as usual, tick, parentheses, delta time, semicolon. And we're going to start off by saying if our overlapped targets is empty, we have nothing to do. So we just return. We do none of the rest. Now, on the other hand, if our, then we're going to make a new variable of type aActor pointer called new closest. And it is going to be equal to DetermineClosest target. And what we're going to check is if it is different, we're going to do something. If it's not, we do almost essentially nothing. So if our new closest is invalid, no. So if it is valid, in this case we need to do else as well, so we can't just get rid of it. So we'll say else here, and we'll get to that in a second. If it is valid, and if, if our new closest is equal to our closest target, not equal, but double equal. If they're equal, then we just return. Because if they're double equal, we don't want to go saying it's changed, because it hasn't, it's the same, so we just don't do anything. Now, on the other hand, we're going to say closest target is equal to new closest. And we're then going to do the onStart stuff again. So let's just copy this here and paste it right after. So onStart overlapping is bound. If it is, we broadcast that it's changed. Now on else, we're going to check if our closest target, why is it running? No, okay. If closest target is invalid, we return. Can't do anything with it. So in this case, it means this doesn't exist. There's no new closest target, this tick we could find. So in that case, we're going to say if it was already invalid, doesn't matter. There was nothing to do. If it is valid, then we want to say if we're just going to use our onStop overlapping this time. So go all the way down here. We'll just copy this one here, paste it here, and remove the empty. We don't care about that. We just want to know if it's bound, then we will call closest target here, and then we will set it to be invalid. So closest target is now a null pointer. And so what this will do is it will say, essentially, if there is no targets to look for, don't do anything. If we look and see if we can find a target. If there is a new target, is it the same as the old one? If yes, we don't do anything. If it is different, then that's the new closest target now. And we let the system know that by broadcasting that it is a different one now. On the other hand, if there is no closest target, if there never was previously, then we're fine. We don't do anything. We already knew. Now, on the other hand, if that is not the case and there was still a valid closest target, that means we have since left, and onStop or overlapping needs to be called because there is nothing left to interact with. And in that case, we then set our closest target to be null so that we don't do this in a loop and we go through here the next time. So now all that's left is we need to do our little extra functions here, which allow us to make this pretty much all functions. So create the definitions for all of these. That's all of them ready here. So let's start with CanObjectInteract. This one is rather simple. We're going to start with an if, and we're going to say if our cast to IRE interact interface fails for our input object, then we return false. And this time, because there is a return value here and not a void, we have to make sure we put a false and not just a basic return. On the other hand, we're just going to say return the same cast, cast like this of object, and we're going to look for ignore interaction. Now, if it is ignore interaction, that means it should be false. If it ignores interaction, meaning this is true, this cannot be interacted with. So we need the opposite, so we'll put an exclamation point here to invert that logic. Next is CanSeeObject. So same thing, copy this. If this is the case, we ignore it. And we're going to need three variables here: an f vector, the start location, semicolon, a f vector for the end location, and finally the f hit result for the out hit. And essentially we're going to just do a line trace. So the start location is, get our cast here, say it's equal to this, and we get our location. So get interaction location. And for end location, we're going to get first person camera component, parentheses, because it's a function, arrow get component location. That is not how you write any of that. Get component location. And get component location is the same as get world location. So it's just a bit named a bit different compared to in blueprints. And with this, we're going to make a boolean as a return, and say hit object or be hit object. And it is going to be equal to get world line trace single by channel, parentheses, out hit is first, and that's going to be the hit result, the vector for the start location, followed by the end location, and finally we need to type what collision it's looking for. So we're going to say e collision channel, two colons, and what we're looking for is ECC underscore visibility, which is just the visibility channel that you're most likely familiar with. If hit object is invalid, so hit object here, if hit object is not true, then we want to return for true. And the reason for this is because we're trying to see if we can see the object. And if we hit nothing, then that's great. That means we can see the object. There is nothing in between the start and the end. And if this passes, meaning we did hit something, then we want to make the check and just see, hey, did you hit the actual object we are looking at? Because if that's the case, that's fine. So we're going to say out hit get actor, which is just getting the actor we hit. If it is double equal to object, then we return true. So this is essentially like an if check here for the return. Is object closer? Now, same thing, copy this and paste it here. We return false if and in this case, I think I made a mistake. This doesn't work. We forgot the parameter. So go back to here. We're looking at this and it's supposed to be a actor object. So this is not, make sure you have it like this. We'll copy it as a whole, move it to here and replace this with our new version. So object should now work. So if this is invalid, we don't do anything, same as usual. Then we're going to say float distance is equal to f vector two colons dist, which will get us the distance between two vectors. The two vectors we are looking for is our cast interact here, our location, so get interaction location, and then we put a comma, get actor location, parentheses. And so what we're going to say is if our closest distance that came in here is double equal to -1, meaning we haven't found anything yet, then we'll use it. Or if the distance is inferior to our closest distance right now, then we want to replace closest distance with the new one is equal to distance, like this. And we will also turn this to true. And if not, we return false and we leave closest distance as it is. And so now we have our final one, which is determine closest target. And so we're going to say a actor pointer, return actor is going to be a null pointer by default. And we're going to say float shortest distance by default is -1. And that's what allows us to do this check here. So now we're going to go and loop through our actors in our array. So a actor pointer array element colon overlapped targets. And so first what we'll do is if our array element is invalid, we can continue. We just skip it. Otherwise, we're going to check all 4 of those conditions by simply going and saying IsObjectCloser, array element, and shortest distance. And we can see object. We're looking for array element, array element, and we can object be interacted with. Once again, array element is the parameter. If all 3 of these conditions are met, then we can say return actor is equal to array element. And at the end of all this, after the for loop, we get to say return actor, like this. And so that does it for everything in C++ that we need to do for the interaction. Now we just need to go and hope that it works. So we're going to do Control F5 to load all of this, and I will see you guys once it's ready. Something went wrong. I must have missed something. This is not correct because it should be player input component as the parameter. And the reason for that is because there is an actual variable called input component, so it's mistaking that for input component. So save that, Control F5 again, and we should have fixed the error. Now that our project is loaded, we need our inputs to be able to do anything. So we're going to go into puzzle. We're going to make a new folder, and we'll call this inputs. Inputs. Okay, so in our inputs, we're going to right click and we're going to make a input action right here. We'll call this IA_interact. And inside of it, we're going to set our triggers. Because our system uses the trigger specifically, we can't use like any other ones. We have to specify what we want. And what we want is pressed. And that'll do. Next, we need to make our input mapping context, which is going to be in input mapping context. So IMC layer, we'll call it. And all we're going to need is our interact for it. So right here, we are looking for key mappings, add one, look for interact, set the key to F or E, whatever you prefer, and we're done. Next, we need to go and actually finish setting up our player character with these inputs and actions. So right now, if we look, the player is a bit bugged. So we're going to need to set that up first. And all we have to do for that normally is we go to our character here. We set it to Manny. Simple. And the same thing for the first person. We look for Manny. There we go. And now, as you can see, the camera is a bit better. We can set our anim class to, I think, first person. It is called, no, FP copy. And the same thing for this one as well, FP copy. Actually, I don't think so. Yeah, for this one, it's unarmed. Sorry. Unarmed. There we go. Now, normally we shouldn't be able to see one of them. One of them will be hidden because it is set up like that. What we need to do now is just rotate the main mesh by 90 degrees and drag it down so it actually fits within our box. So compile, and all we have left to do is we need to now link up the inputs. And the way we do that is we go to our class defaults, we go down in here and we look for our input section that we created. So keep going here, and most likely at the bottom. Yeah, here it is. So this is what we're looking for. So input mapping context right here. We're looking for our IMC player. Interaction range 500 works. Interaction action is interact. Success, we will just say compile success, and fail will be compile failed. So for some reason, I'm not sure why, but it's I do know why. It's deleted all this, and the reason is because it is in a base C++ class, so it doesn't have this information by default. So we have to give it to it here, even though if we go over to the horror specific map, it already has this information. That's because it is using a blueprint that inherits directly from that and has already been set up in the project. So we need to give this the different actions. So it's IA sprint, jump, move is going to be, I believe, just move as well. Look action is look, and mouse look is mouse look. And I believe that should be everything needs to be set up. So right now, if we now play, before our character was a bit bugged, now it should be normal and movable. Apparently not. Oh, wait, sorry. The reason is because we also need to give it some more mapping contexts, because this alone isn't enough. We need to add the default, we need to add the horror, and we need to add the mouse look. And so that should give us the result we need. There we go. So now we can actually look around, we can see our character, and we can run. It's not perfect, but it works. And there is no widget on screen. Now we need to add that part to it as well. So we're going to go to our puzzle piece. And I'm not sure if we had an actor for this, but we're going to look, as you can see, we didn't even look at this last time, I completely forgot. But we have our component, our static mesh, and we also have our overlap. Now the overlap will set to something like 1000. So that within 1000 we'll have one icon, but within 500 we will have the interact option. For the piece, we will look for our puzzle piece, and that's exactly what we want. So if we now compile and save and just place this in the scene, let's put it over there. If we walk into range, it should display it. We get close enough. There we go. So as you can see, it's working. It's just underground because that's where the object is. If we get close enough, it should display F and we can interact with it. And normally if we press F, it should disappear. And we got a little sound. You guys can't hear it, but there was a sound to indicate that it succeeded. And the object is gone. The UI is gone as well. Let's put a second one so we can test the distance system. So right now, if we walk in, there are two. So this one is closest right now. If we move a bit towards here, that one becomes closer. And it will keep doing that. If we go and pick up that one, this one now becomes closer. And that's working as intended as well. If you press F again, it disappears. It worked first time. We didn't have to do any updating, any fixing. So that's great. That will do it for this part. Thank you guys so much for watching. Thank you to everybody on Patreon who has been supporting me. In the next part, we will be going over setting up the pawn in C++. I'm not sure if we will have enough time to do everything, but that's at least what we're going to try and do in the next part. I will see you then. Thanks for watching. Goodbye.